English.
Yeah. Well, what you saw here, I should comment that this motor was done almost in a handcraft basis. It's made of wood, done by hand. It doesn't have the mechanical precision of a factory, of an industry, the quality control of an industry. You see the shaft is wobbling a little. So if we do that with mechanical precision, the efficiency would be even greater than that. So imagine what we can do. If you consider that, for example, 40% of all motors in the world, electric motors in the world, are AC monophasic motors of low power motors, this is what you see, the difference of gain, if you can change immediately the Keppe motors for all of these 40%.
Yeah, the point is that the technique, the theory behind this is so solid that it creates enormous savings in energy, even in a simple motor. Imagine something that's even much more sophisticated in bigger applications as well. Imagina uma coisa mais ampla ainda. Se tem esses resultados com coisas simples, imagina no maior. Então, o Keppe Motor, os princípios atrás disso são tão profundo, muito profundo.
O Eduardo, um amigo nosso, ele fez uma apresentação no COP15, agora, alguns meses atrás, lá na Dinamarca. Nós fomos convidados pelo próprio governo brasileiro para apresentar o Keppe Motor na Dinamarca. E um dado muito interessante que ele levantou é justamente esse, que se todos os motores de baixa potência, que é o estágio de desenvolvimento do Keppe Motor hoje, né? Se todos os motores elétricos forem substituídos pelos Keppe Motors hoje, você poderia, só no Brasil, hein? Só no Brasil, você poderia parar a usina de Itaipu completamente por 2 meses e meio. Sabe o que significa isso? 14 turbinas, 1 milhão de megawatts cada uma, parada por 2 meses e meio.
It's a very important statistic for them to understand in English now, for those who are watching from other countries.
One of our friends, Eduardo, we were invited, the Stop Association was invited to the COP15 in Denmark this past months. September, it was November, September. Yes, the end of last year, then in Denmark, to present the Keppe motor. And one of the data that Eduardo brought to the audience there is that if the low-power motors were replaced by Keppe motors now in Brazil, only in Brazil, which is the right stage of development of the Keppe motor today, we could do that immediately now, it would save 2 months and a half work of the Itaipu hydroelectric power plant.
Which generates how much power?
It's 14 turbines working at 1 million megawatts each. So you can make an idea of what that is.
It would substitute this hydroelectric power plant for 2.5 months if we replace all the low-power motors in Brazil today with the Keppe motor.
Imagine, because these motors represent billions and billions of motors all around the world. More motors like that than people. There are more low-power motors, electric low-power motors, than people in the world.
Tem mais motores de baixa potência do que pessoas na Terra.
No mundo,
Então,
it's amazing.
Imagina se a gente pode repor imediatamente esses motores tradicionais com o Keppe Motor. Não só no diminuição do poder, mas na diminuição da poluição também. Os efeitos colaterais que os motores tradicionais têm.
Okay, so...
Outro vídeo?
Let's pass the...
Okay, so we have another video now to...
Yeah, we see talking about low power motors, the solar panels. They need low power motors because if you have a high power with solar panel, you need kilometers of solar panel to work. So our motor makes very viable to use the solar panels with motors.
So you wouldn't need the electrical field directly, then you could use the power from the sun.
Yes, you can move motors with the power of the sun.
Fala isso em português, Roberto, é muito importante.
Então nós vamos ver agora um vídeo de utilização do Keppe Motor com painel solar, porque os painéis solares precisam de motores de baixa potência, porque senão precisaria quilômetros de painel solar para mover um motor de, 10 kW, né? Então, o nosso tipo de motor viabiliza muito uso da tecnologia do painel solar para motores, né?
Hello, I am Cesar. I am together with my friends, developers of the Keppe Motor. Here is Roberto and Alexander Fascari. And what we have here is a fan, domestic fan running with a Keppe motor. And this Keppe motor is running this fan with a blade for a 50 watt equivalent fan, conventional motor. So this blade is spinning at 676, 680 RPM, around that. This is the spin, the rotation of a 50 watt fan, equivalent fan, right? And so we are here in São Paulo with a very cloudy day, as you can see, and we are going to demonstrate the consumption of the motor. The motor is consuming now, this is ampere meter, okay? Let's zero it and measure it here. The motor is consuming 0.5 amps with 12.1 volts. From the battery, right? This means this motor is consuming 6 watts to run a 50 watt motor, equivalent motor, right? So this makes already a gain of more than 80% energy. And what we have here is a solar panel, right? It's a 20 watt solar panel. And as you can see, the sky here in São Paulo is very cloudy today, which means we do not have direct light onto the solar panel. And I'm going, Alex, can you please plug in the solar panel to see the result on the motor? Now with the solar panel, we can measure again what is coming out of the battery. That consumption diminished to 0.3 amps, which means the motor, Keppe motor now is consuming 12 times 0.2, 0.3, 2.5 to 3 watts only, with no sun at all. Right, with no sun at all. This is very important to emphasize. But now we are going to wait for the clouds to open a little bit, and we are going to show what happens to this system, solar panel, battery, and the Keppe motor. We are down here in São Paulo, a city in Brazil, in the very limit of the parallel 23, which means we are in the middle of the tropical and subtropical climate. So this is not the best area in the planet to collect the solar energy. But we are going to demonstrate how a very small solar panel with 20 watt solar panel, we can run in a cloudy day a 50 watt motor, a 50 watt fan, with a Keppe motor consuming practically no energy at all, and the battery being fed by the solar panel as well. As the sun rises, this negative number increases. 0.2. You can see here the sun is beginning to appear. 0.3, 0.4, 0.5, 0.6, 7. This means that the battery is recharging very, very fast, as you can see here. 12.6, look, the battery is receiving 0.8 amps and increasing its voltage. And the motor is still working.